Yeah, there you go. All right. All right. So anyway, we've actually worked a long time. We've been working a long time on this chapter, and I mentioned to you this chapter did have a lot of stuff in it. So that's why I would teach it. The next day I'd review and reteach it, and then we move on. And I try to always overlap and reteach it. And that's when you're supposed to pick up maybe some gaps that you had. Now, the other thing we're doing, and we started this yesterday, is I gave a practice test, and I was kind of impressed. Some of you were doing exactly what I wanted you to do. You sit in a group and you test each other. Say, well, how do you know? How do you know that has that 3 sig figs? And that's how you learn it. You learn it by talking. You don't learn it by just sitting there and say, I hope I do well on my test. That's not going to work. The other thing is, almost everything you need to know is in this packet, isn't it? This is pretty much what the test is on. And if you look at that practice test, you'll see it's here, isn't it? Now, somebody mentioned to me, and I maybe I forgot, but they said that there was one part of this page that I didn't do. And so I do want to review that real quickly. And then you have the rest of the period to either work on your homework assignments. Remember, you do the odd questions. You only do 2 if it has multiple sections in it. And then you can work with each other on that. You can also, I would definitely work on the practice test. That's actually better than going home and doing the homework. Get that? If you work on the practice test, you'll understand how to do the homework. And I can walk around the room today and help you on the practice test, can't I? And then you go home and say, well, now I know how to do this. All right, remember the temperature? Do you think there's going to be some temperature converting? Okay, so the first thing you do, subtract 32.59. Yeah, everybody got that one down? How about the other one? The other one that changes Celsius to Fahrenheit? You have that one down? Okay, and then Celsius plus 273 is Kelvin. Everybody got that? Okay, now I don't think I had finished this over here. Ready? The Kelvin scale is the SI unit of temperature. What is SI? And that's the modernized, they took the metric system and they modernized it around 1960, and they made it into the international system. And it's called we call it the System International. That's the SI. The Kelvin scale is also called the absolute scale because its 0 is what? This is on Jeopardy. This was on Jeopardy 2 days ago. What is the coldest temperature we think you can get? Absolute 0. And that's the only scale that's actually 0 on the scale. The Kelvin scale units are the same size as a Celsius unit. So if you were to jump up 10 degrees Celsius, then how much higher would you go on the Kelvin scale? They don't start on the same numbers, but how far would you go? Like, look at this. If this is ice and this is boiling water, how many Celsius degrees separate these two? 100. I'll go over here. How many? 100. That means the only difference between the Kelvin and the Celsius scale is that you take away the negative numbers and make the lowest number you can think of Celsius and make that 0. So what's the scale that has no negative numbers on it? Which temperature scale has no negative numbers? Kelvin. And that makes sense now mathematically. What's twice as hot as 5 Kelvin? What's twice as hot as 5 Kelvin? 10 Kelvin. That doesn't work over here. What's twice as hot as 0 degrees Celsius? That didn't work. What's twice as hot as -5? -10? No, that doesn't work, does it? That's why they use this in mathematical equations. There are no negative temperatures in Kelvin. Almost all chemistry and physics equations, if you do mathematics with temperatures, you have to change it to Kelvin. But we're going to use Celsius in here, and the rest of the world kind of uses Celsius. It's only when I have to use some mathematics that I might change it to Kelvin. Who is the Fahrenheit scale named for? Right, Gabriel Fahrenheit. Who is the Celsius scale named for? And you don't have to know their first name. Anders Celsius. His last name was Celsius. Who is the Kelvin scale named for? And his name, you think it was, his name was what? He did a whole lot of work. His name is William Thomson. What? Okay. Well, anyway, what happened is he did so much stuff in science that in London, in England, they knighted him, and they gave him, he was a baron over a certain area, and the Kelvin River ran through that area, so they called him Lord Kelvin. So William Thomson became Lord Kelvin, and so the Kelvin scale was named after William Thomson, also known as Lord Kelvin. Yeah, somebody had their hand up.
What was the one for Celsius?
His name was Celsius. His last name was Celsius. Thanks for raising your hand. That's important. And Fahrenheit is... Okay. There's only one temperature in which Fahrenheit and Celsius read the same number. And if you want to find that, it might be somewhere on the test. It might be a bonus question or something like that. But there is one place where if you put a Fahrenheit and Celsius thermometer, they would read the same number. There's only one number that does that. Okay. Let's see. Okay, that's enough for that. I think I'll stop with that. Now, do you have any quick questions for me? What I'd like you to do is, whether you're tired or not, say, I can do this. For the next 40 minutes, can I get in a group, take the practice test, and say, I know how to do... by the way, if you don't know your prefixes and power of the 10, I cannot help you tomorrow. You will not do well if you don't know those. You got it? Didn't you do flashcards on those? Didn't we do a quiz? I mean, how much can I do for you? So if you don't know those, you're in trouble. Do you know how to do scientific notation? Do you know significant figures? Do you know how to do calculations with sig figs? Do you know how to change temperatures? That's what that practice test did, right? All right, I am finished, and you may go ahead and get in your groups. If you want to work on homework, you can work on homework.